Hi, we're going to look at graphing the basic form of logarithmic graphs. We're going to take a real close look as to why certain things perform the way that they do in this case. So first off, there's three steps to this whole thing. First step is, what is the base? My base is a little number hanging out after that log. So we're going to say that this is b equals 2. Okay, then part two is we have a set of coordinates. This right here, 1 over b comma -1, 1, 0, and then b comma 1. This will never change. So it's kind of like a formula within the problem now. I now need to take my base that I wrote as 2. I'm going to drop it in place of these two spots. Notice that this middle one does not change ever. So b is 2, goes right in, and this one turns into a fraction. Now I want to take these three coordinates that we just created and just graph them. Okay, so we're going to go over a half, we're going to go down 1. We're going to go over 1, up 0. We're going to go over 2, up 1. Now this graph generally always performs and behaves in the same way. Now what's the behavior? Well, this line over here, you got this big arch going. This line will forever go to the right, and it's always going to go up, but very slowly. Very quickly to the right, very slowly it's moving up. It's never stopping in both directions, always moving. This side, though, as we go down very quickly, its line is kind of creeping over to this y-axis, but it's never actually going to hit it. We say that that is an asymptote. A what? An asymptote. Asymptote means where there is no answer. And we're going to have no answer when x equals 0, which is this line right here, which is also happens to be our y-axis. So again, asymptote says, where is there not going to be an answer? Well, at 0. Why though? Here's where we're going to look a little deeper. Okay, so let's take our problem over there. F of x equals log base 2 of x. And I want to rewrite this in, I want to go back and forth between logarithmic form and exponential form. So what if I had my problem and instead of f of x, I said y? Okay, well, remember to change from log to exponent, we take our base and we shift it over and we're saying x equals 2 to the y power. Okay, why are we even doing this? Well, we're saying that we can't hit 0, right? Let's take 0 and can I get an answer of 0? Is that possible? Well, now we need to look at how do exponents perform. 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, and let's go in the reverse. Okay, each one of these, let's start here, 2 to the first power, 2 times 2 is just going to be 2. 2 to the second power, 2 times 2 is going to give us 4. 2 to the third, 8, 16, 32. Okay, what's happening as we move to the right? Well, we keep doubling our answer. We keep multiplying by 2. What happens if we move in the reverse, though? 32 to 16, we cut it in half. We divide by 2. 16 to 18, we cut it in half, cut it in half, cut it in half. That pattern's still going to happen as we move backwards. So let's take 2 and cut it in half. 1. Let's take that, cut it in half. 1 over 2. Take that, cut it in half. 1/4. Whoa, what's happening here? Well, first off, there is a little bit of a pattern. Going back to our rules of our exponents, when you take a negative exponent, remember you can move it down to the bottom, push it to the bottom, turn to a positive. But also, look, if this is our middle, 2, 1 over 2, 4, 1 over 4, 8, this is going to have to be 1/8, and then 1 over 16. Think about this. If you're still unsure of what's happening with these fractions, let's take a whole pizza pie. You're the only one there. You get that whole pie. But all of a sudden, cut that pie down the middle. Now you have one, you have a half, you have a half. Cut that thing into 4 slices, cut it into 8 slices, cut it into 16 slices, cut it into 32 slices. Each time you're getting smaller and smaller and smaller, but the pizza's not disappearing. So what's happening is we could theoretically keep cutting those slices smaller and smaller and smaller. It's never actually going to disappear. That's what's happening here. So why am I doing all this? Because can I raise 2 to any number to make it equal 0? Well, if I go in the positive, no. If I go in the negative, I just get smaller and smaller numbers. I'm never actually going to hit the 0. That's what's happening to this line. We're getting closer and closer and closer. We're getting smaller and smaller slices, but it's never actually going to disappear. So we never hit that x equals 0 or that asymptote. And that's graphing a basic form of logarithmic graph with too much explanations.